did it right.
Okay, so what you saw last block
Are you recording?
was this,
Whoa,
right?
I'm on our YouTube channel.
But just by looking at the problems last week, the homework problems, you could tell me how it moved left and right, how it moved up and down, and stretches and compressions. Okay, we call this vertex form because just by looking at it, you can say what the vertex is, how it moved left and right, up and down. Okay, that's the nice pretty form because just by looking at it, plugging in my calculator, I pretty much know all the properties of that quadratic. So if you look at the homework today, we are now going to look at standard form. And standard form looks like this. There are no more parentheses. You can't tell just by looking at it how it transformed. Okay? In standard form, what you need to know is that A is always the number in front of x squared, B is always the number in front of x, and C is always your constant term. So when I give you some formulas with A, B, and C, that's where you find the numbers for those variables, A, B, and C. Okay. So we're going to do about 5 things with each quadratic of standard form. The first thing we're going to do is determine if it opens up or down. Okay. And I know a parabola would open up or down because if what happened? What happened to a parabola to make it open down? A reflection, okay? And you can still tell that by looking at A. If there's a negative or not, that means there's a reflection and then it opens down. So if A is positive, greater than 0, it's going to open up. If A is negative, less than 0, it's going to open down, okay? So 2 things with this. If it opens up or if it opens down, one of them is going to be a minimum and one of them is going to be a maximum. If it opens up, that is a min because it's a minimum value. I'm only going up. If it opens down, that's a max value because I can only have a maximum height and I'm only going down from there. Okay? So if it opens up or down determines min or max, and that's the first important property of a quadratic, if it's a minimum or maximum. Okay? The second thing we're going to do is calculate the axis of symmetry, and that's a formula. And your formula is x equals negative b over 2 times a. Where do you get the b and a? Right up here. B is going to be the number in front of x. A is going to be the number in front of x squared. Okay? And that's going to be your axis of symmetry. That's the symmetrical line, right, that goes through your parabola, and you know that it's going to be reflected over that, right, both sides. Then we have the vertex. And a vertex is an xy point. I know that the vertex is always on my axis of symmetry. So whatever number I get here for my axis of symmetry is going to be the x value of my vertex. Okay. Now, if I have this x value of my vertex, how do I find the y value? If I have the input, the x value, how do I find the output, the y value? You sub it in, very good. You sub x into your equation. Right? Sub x into your equation, whatever your equation was up here, and your answer, that your output would then be your y value. So you get the x of your vertex from here, the y from subbing it in and solving. And then fourth, you're going to find your y-intercept. The y-intercept, by definition, is when x is 0. So think about it. If x is 0, what happens to these 2 terms up here if x is 0? They're going to cancel out because anything times 0 is 0. So if x is 0, these 2 terms are gone. What's left? C. So your y-intercept is whatever c is because the x terms go away. Okay. And then the last thing you're going to do is domain and range. Domain, on a parabola, since I start at the vertex and go left and right forever, my domain is going to be all real numbers. Now my range is going to differ because it depends if I have a min or a max. If I open up, my range is going to be greater than or equal to, right? Because I'm starting here and only going up. If I open down, my range is going to be a less than or equal to, because I'm here and I'm only going down. Okay. Okay. So the first thing I like to do when I'm applying all 5 of those steps is to identify what's A, what's B, and what's C. Right? A is going to be what? 1. B is going to be 6, and C is going to be 9. Okay? Identify the A, B, and C. Then I can go to step 1 and say, does this parabola open up or down? Well, I look at A, and A is positive. That means there was no reflection, so it's going to open up. And if it opens up, is that a min or a max? A min, very good. It's a minimum if it's opening up, right? Because there's a minimum value, I go up forever. And then step 2 is to find my axis of symmetry. So negative b over 2 times a, which is going to be a negative 6 over 2 times 1, which is negative 3. And then that's the first thing I can graph. I can go negative 3 and put in my axis of symmetry. Then once I have my axis of symmetry, I know my vertex is going to be somewhere on that axis of symmetry, but I don't know what I did up and down. Right now I know I went left 3, but how did I go up and down? So then step 3 is to find your vertex. And what I know so far about my vertex is that x is negative 3, because I know that this axis of symmetry is the x of my vertex. So to find the y value, we're going to sub this negative 3 in for the x and solve. So I would have a negative 3 squared plus 6 times negative 3 plus 9, which would be 9 minus 18 plus 9, negative 9 plus 9, which is 0. So I can graph that. My vertex, negative 3, 0. And then my last step, the y-intercept. The y-intercept is always when x is 0. So if I put 0 in for x, those 2 terms go away, and my y-intercept would be 9. Whatever c is. The y-intercept is always what c is. Okay. And how does that help me? Is because if I go to my y-axis and graph the y-intercept of 9, this axis of symmetry says that this point will get reflected over that because it's symmetrical. So if I'm 3 units to the right, I can go 3 units to the left and put another point. That gives me both sides of my parabola. And the last step, 5, my domain in range. My domain is going to be left and right forever, all real numbers. Domain is always all real numbers. That will never change. But range, you have to think about range because I'm starting at y equals 0 and I'm only going up. So the range on that would be y is greater than equal to 0. Okay? Where am I starting on the y and am I only going up or am I only going down? That'll be your inequality sign.
That was complicated.
So again, let's label what A, B, and C are. A is 4, B is, and C is good. Okay? So once I know my A, B, C, then I can start going through my steps. Step 1 is, does this parabola open up or down? And it's going to open up because A is positive. There was no reflection. If it opens up, is that a minimum or a maximum? A minimum. Very good.
Do we have to write all this down?
Mm-hmm. axis of symmetry is negative b over 2 times a. So that's a negative 12 over 2 times a, which is 4. So that would be 12/8, which reduces down to 3/2. Okay. And once I have that axis symmetry of 3/2, I can graph 1.5. So I can graph that in. I know my parabola is going to be somewhere on that axis of symmetry, but I don't know how to go up and down yet. So my next step, my vertex step, tells me how to go up and down, because I know from my axis of symmetry that I went 3/2 to the right, but how did I go up and down? My y value? So you're going to sub 3/2 in for x of your equation up here. So that would give me 4 times 3/2 squared minus 12 times 3/2 plus 9. And you'll probably want to use a graphing calculator on this, or you can do mental math if you wanted to. This would be 18. So 9 minus 18 is negative 9. Negative 9 plus 9 is 0. So 3/2, 0, I can graph that. That means I'm on the x-axis again. And then to get the rest of this parabola, I need a y-intercept that I can reflect over. So step 4, my y-intercept is going to be 0, 9 again. That's my c. So I go up 9, put a point, and since this is 1.5 units from my axis symmetry, I can go over 1.5 units. I can reflect it over. And then I have my parabola. So then my last steps here would be domain and range. Domain, of course, is all real numbers. It's always all real numbers. My range would be y is greater than, because I'm going up from my vertex, so y is greater than or equal to 0.
Why did the 4 times 9?
So let's label the ABC. A is 2, B is, and C would be, right, if it's not there, it's 0. So when you're doing quadratics, B could be 0, or the C could be 0, or both of them could be 0. A could never be 0 because then the x squared term would go away and it's not quadratic anymore. So you have to have an A term, but B and C could be 0. Okay, so does this graph open up or down? A is positive, so up. Would that be a max or a min? Good. Axis of symmetry, negative b over 2 times a would be a negative 1. So I can graph that, negative 1. And then I can use that negative 1 for my vertex, because I know the x of my vertex is negative 1. Therefore, find the y, the output value. So I've sub negative 1 in for x and solve. 2 times negative 1 squared, which would be 2 minus 4, which is negative 2. So I can graph that, negative 1, negative 2. So in order to get the sides of my parabola, I need to do what the y-intercept is to reflect. So the y-intercept, put 0 in for x. They both go away, so it's 0, right? Or it's whatever c is, 0. So my y-intercept is actually the origin, and I can reflect that point over the axis of symmetry. Have my parabola. And then finish off this problem, my domain and range. Domain, of course, is all real numbers. Range would be y is greater than or equal to negative 2, the y value of my vertex. The range is always defined by the y value of the vertex. So let's do one more of the reflection.
we just...
All right, let's do our A, B, and C. Last one, I want to just show you reflection, right? A is -6, B is -12, C is -1. So step one, is this going to open up or down?
Yeah.
This one's going to open down because there was a reflection. So if it opens down, is that going to be a min or a max?
Max.
A maximum. Right? If it opens down, that means there's a maximum height. My axis of symmetry, -b over 2 times a would be 12 over -12, which is -1. Right? Double negative becomes positive. So 12 over -12. And what does that do? That tells me the axis of symmetry is here at -1, so I can graph that. And my vertex is going to be somewhere at -1. Right? -1 what? That means I went left 1, but I don't know what I did up and down yet. So I sub in -1 into my equation. So -6 times -1 squared, which would be -6 plus 12, which would be 6 minus 1 is 5. So I know my vertex, I went left 1, up 5. And then what? I need another point to reflect, so I can say, oh, my y-intercept is -1. So I go down 1, put a point, and then this point, this y-intercept point, is the point I reflect over the axis of symmetry. What some students will do is that once they do many of these, they'll start getting their points mixed up and they'll start reflecting the vertex point over the y-axis. So make sure you're always reflecting the y-intercept point. So domain, of course, is all real numbers, but the range, this one changes. Since it's a maximum, my range can only go down, so it would be less than or equal to the 5.